Okay, let's go ahead and graph this equation. And what are we talking about here? Well, we're talking about trigonometry. You can see we have a trigonometric function, sine. So this type of problem is something that you would see in a course like pre-calculus. It's pretty typical to take trigonometry within a pre-calculus course. So for most of you out there, you're going to see a problem like this again within a class like pre-calculus. There are some standalone trigonometry courses, but the topic here is trigonometry. It's not as common as it used to be to just have a basic trig class all by itself. Typically, trigonometry is taught within a broader course like sometimes it can be taught like with an advanced college algebra, maybe an advanced algebra, but most typically it's in a pre-calculus course, and this would consist of about 4 chapters of that particular course. You know, it could take you a good 3 months of study within a particular course. So there's a lot to learn here. And if you haven't seen something like this, well, there's a lot of foundational stuff that you need to know. So this particular problem and what I'm going to be doing here is kind of designed for those of you that are already studying trigonometry within one of these courses I just talked about, and you already have a basic sense on how to graph trigonometric functions like sine, cosine, and tangent. All right, so if you haven't done any of this, certainly stick around just so you can kind of see how this works. But I'm going to show you the correct answer in just 1 second. And what we are talking about here is sketchiness. Okay, we're just going to create some sort of basic sketch, pencil and paper. But I will say this, it's important for those of you that are at this level of mathematics to know how to use a graphing calculator, right? And it's almost always a requirement to have a graphing calculator to graph functions like this, something like a TI-84. So make sure you know how to use your graphing calculator if you're in one of these classes. And of course, you can double check your work that you do with pencil and paper with your graphing calculator. But anyways, I'm going to show you the correct graph to this in just 1 second. And then we're going to talk about all these lovely components to this graph, which would be what? Well, we're talking about amplitude, the period, wavelength. We're talking about shifts up or down, left or right, all this kind of good stuff. So we're going to get into all of this in just 1 second. But first, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I have been teaching math for decades. I absolutely love helping people learn mathematics. I'm going to tell you right now, all of you could be successful in math. And I'm especially speaking to those of you that are having a tough time with math. Maybe you were like really awesome at math and now you reached a level of math, maybe like pre-calculus, and now things are getting kind of more difficult for you. Please don't give up. You can be successful. But what you need is great math instruction. Okay, you need to learn from someone or something that you actually understand, especially with a topic like what we're talking about here. It's very technical and it can get very confusing. All right, so the way I like to teach math is to explain things in easy to understand language so everyone can get this stuff without watering down what you need to know. So if you need help in your current math course or maybe some sort of special test that you're getting ready for that has math on it, I'm talking about things like the SAT, maybe a teacher certification exam or a CLEP exam, or if you're homeschooling mathematics, check out my Math Help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span all these categories and much, much more. Specifically, if you need help with this, with trigonometry, you'll want to check out my pre-calculus courses, okay? So I have a couple different versions of them. That's where you want to go if you need help with trigonometry. I'm also going to leave links to my notes in the description as well. A lot of you take pretty good notes, but you need to take the best notes as possible in order to be as successful as possible in math. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and take a look at the basic sketch of this equation here. All right, so it's an equation of a trigonometric function, and we're talking about sine. Let's go ahead and take a look at this sketch, and here it is. All right, so you can see right here is the basic sketch. Now, your sketch might look differently, and now this thing goes on and on and on, and I'll talk about why that is in a moment, because we are talking about things called periodic functions, right? These are just waves that just keep repeating, repeating, repeating. So sometimes you can be told to sketch out 2 wavelengths or 2 periods. But anyways, this will give you a basic sense of what the graph is. And when you're asked to graph a sketch of a trigonometric equation, okay, you want to put in some key things like amplitude, right? So the amplitude for this particular, well, first of all, let's start off with the main axis here. That would be the equation y is equal to 2, okay? And then we have an amplitude of 3, okay? That's the wave, that's the height of the wave, all right? So it's going from 3 down to -3, but our axis, it's been translated up 2. We're going to talk about all this in a second. So our amplitude, okay, would be maxed out at 5, and it would be bouncing at -1. All right, so you want to show these critical points, and then of course right here we want to define the period, which is 1 wavelength, and that would be pi units. And then you can even put in some more critical points right there, but this is the minimum, I would say, to get this problem correct, like on a test. And most of you are, probably interested in watching this video so you can ace your test, quizzes, and your final exams, which is awesome. But anyways, if you got this correct, let's go ahead and celebrate by giving you a nice little happy face and A plus, a 100%, and a few stars so you can tell your friends and family that you know how to graph a sine function. All right, so let's kind of do some quick review of some of this basic stuff. So we're talking about periodic functions, right? So when you study sine, cosine, tangent, and then the inverse is the respective, cosecant, secant, all this other kind of good stuff. Now, by the way, if I'm speaking in terms of language and you're like completely lost, well, you need to, go back, you need to go back to the basics, right? Or maybe you just need to learn the basics for the first time. So again, this video is designed for those of you that are kind of studying this right now. But let's just review some basic concepts. So periodic functions, right? So the graph has a pattern that repeats indefinitely, right? So like a sine graph or cosine graph, it's just going to go on and on and on forever. So when you're asked to graph these things, you're only going to, get, one wavelength, one period, or maybe you could ask to do 2. Okay, but just understand that the graph goes on indefinitely. That's a periodic function. So let's take a look at the basic sine graph. Y is equal to sine x. So if you don't understand the basic sine graph, well, there's no way you're going to be able to do a problem that's a little bit more complicated like the one that we're dealing with right here. But this stuff is not that difficult. But just a quick review. Sine starts here at the origin, okay? And again, this continues on this way, this continues on this way, and it has an amplitude of 1, okay? So in other words, it's going to be going up to +1 and down to -1. So it starts at 0, 0, and at 90 degrees, or pi over 2 radians, it tops out, okay? So if you were to get your calculator and go, oh, what's sine of 90 degrees? It would be 1. Okay, so or the sine of 0 is 0, and then it, right here just kind of comes back down, and at pi, or 180 degrees, it's back down to 0, and then it continues to go down all the way down to -1 at 3 pi over 2, which is going to be 270 degrees, and then it's going to come back and do a U-turn up to 2 pi, which is 360 degrees. So this is one period of pi, and the value, I'm sorry, one period of sine, and the values of sine along this curve. You need to be able to interpret these graphs to help you with other types of problems. So, that's the key to really master math. You just don't want to blindly do problems like, oh, I am going to graph this thing, and I really don't know what I'm doing. I'm just going to, you can say I'm trying to use my little robot voice here, right? And too many students kind of thinking that way, like, oh, here is a problem. I'm going to do this, this, and this, and this to actually get the problem right, without thinking about how it relates to the bigger topic, the bigger aspects of mathematics that you're trying to learn, right? So all this stuff is interconnected, and at this level of mathematics, it's just pretty sophisticated math. You need to be thinking about the graph, the information it's telling you, etc. So this is the basic sine graph, and what we're going to be doing here is translating it, okay? In other words, we're going to do stuff to this graph so we can move it We can move this thing from left to right, up and down. We can make the wavelength or the period longer or shorter, etc., etc. So that's what we're doing in this particular problem is we have an equation right up here, and it has an impact, all right? So like the amplitude is going to be different, etc., etc. But before you start graphing more sophisticated things, make sure you have a good solid foothold on just the basic critical points of trigonometric functions, specifically sine, cosine, and tangent. Okay, and then of course, once you master those, then you move on to cotangent, secant, and cosecant. All right, so let's go ahead and take this a step further and review some of these basic concepts. All right, so the amplitude, right? So the amplitude of the graph is y equals a sine bx, or in terms of cosine, y is equal to a cosine bx is the amount by which it varies above or below the x-axis, okay? So you'll see here that the amplitude is going to be this coefficient a. All right, so this is some stuff that you might want to have in your notes if you don't already have your notes available to you. By the way, when you join any one of my courses in my math help program, I have detailed notes all there. It's super easy for you. Again, for this particular topic, you want to check out pre-calculus. All right, so the period of each graph is the length, okay, of the shortest interval on the x-axis which the graph repeats. All right, so just some basic review, basic concepts. So here, given an equation, a sine bx, or y is equal to a cosine bx. We'll throw cosine in as well because they pretty much work the same way. So if you know how to do sine problems, like this particular problem, you can just do the same. It's the exact same steps for cosine. However, cosine has a different base graph, right? Its graph does not look like sine. It's a little bit different. But anyways, let's talk about the amplitude. So the amplitude is the absolute value of a. So whatever this coefficient is, this number in front of sine or cosine right here, if we take the absolute value of it, that is the amplitude. Again, that's how far it goes above and below the x-axis. And then the period is the length, okay, of the shortest interval. It's basically a one wavelength, okay, and that's going to be 2 pi over the absolute value of b, and b is the coefficient of the function, whatever's inside the function right here. Like if we had a 2x, it's that right there. So make sure you understand the location of these variables. Oftentimes students get confused about this, but anyways, that's the amplitude and that's the period. We're going to have to calculate each of these here for this particular problem. And then also we're going to have to consider shifts. So shifts are up and down or left and right movements of the graph. So that's going to get more interesting. So we can kind of expand our definition or our formula for amplitude and the period into something more involved like this. So let's take a look at this equation for sine and cosine. They're the same thing, but let's just focus in on sine because that's what we're doing. So A is going to be the amplitude. Okay, so the variables here, how to find the amplitude and the period, will be the same. Okay, so here's B is the coefficient in front of the x, and then we have a c here as well, or we can have a c. This will be an example of, like, let's say you had y equals 2 sine 3x minus 1, okay, or plus negative 1 plus 7. This negative 1 would be c. Okay, now in this particular problem, c is 0, so sometimes you won't have these variables, but if you do, that's where c will be located. And then we have this number on the very outside, which we'll call the variable d. So in this example, would be like a 7. Okay, so let's go ahead and using these variables. Okay, let's talk about the shifts once we have an equation with these respective variables. So if d is greater than 0, then we're going to be shifting the graph d units up. Okay, so for example, in this basic little thing that I made up right here, plus 7, that's greater than 0, so it's going to be we're going to translate that graph. We're going to move it up 7 units. Now, if you're already overwhelmed, I totally get it. You're going to have to go super nice and slow with this. You're going to need your notes, some graphing paper, and just take your time. Don't try to, don't go for quantity when you're learning this stuff. Don't be like, oh, I need to do a lot of problems quick. No, go for quality. Learn how to do one problem. Learn how to master one problem. Once you get that down, then take on another problem, because there's a lot of things going on. Don't try to do like, oh, I'm going to do this problem real quick. Oh, I got it wrong. Let me try another problem real quick. No, that doesn't work that way. There's just too much information. So just master one problem at a time. Okay, so if d is less than 0, and then we're going to have a shift of absolute value of d units down. And then if we have a c value, in other words, a value like right there, right, in this particular problem, okay, right here, see if we have a C value. In this particular problem, we don't, but if we did, C over B, if that's greater than 0, then this would be a shift to the left, right, which would be C over B units to the left. And then if C over B is less than 0, we're going to shift absolute value C over B units to the right. You can write all this down in your notes. And then, of course, we have the formula for the amplitude and the period, which I already kind of went over. Okay, so there's a lot of things to consider here, right? We need to look, hey, what's the amplitude? What's the periods? What are the shifts, left or right, up or down? And then guess what? One thing I didn't even put in here is reflections. So a lot of you are like, reflections, what's that? You might be like, this is just too much. Well, listen, one step at a time. Okay, these problems do take time and you have to be patient and focused. All right, so here we go. Here is our problem. So it's y equals 3 sine 2x plus 2. So what we want to do is just match this up to the general equation that I kind of described. So we have y equals a sine bx plus c plus d. All right, so 3 is going to be our a value, okay, which represents the amplitude. Our b is 2. Now there is no c. This is 2x plus nothing, and there's 2x plus 0, so there is no c value, so we don't have to worry about that. And then 2 is our d value, okay? All right, so now we're going to use all these formulas right here to go ahead and get this respective information. So 3 is our amplitude. 2, this is our 2, so we can get our period, so that's 2 pi. This is 2 is our b value, excuse me. So 2 pi over the absolute value b is 2 pi over the absolute value of 2, which of course is pi, right? So you can just see that work right there. And then we're going to have a shift of 2 units up because this is positive. All right, so we have the basic sine value. Its amplitude is going to be increased to 3. Its period is going to be decreased from 2 pi to pi. And then we're going to shift that thing up 2. So how do you do this? Well, stylistically, there's different ways. I'm going to suggest to you that the first thing you want to do is put in your new axis, right? So here is the x-axis. On a normal sine graph, you're using the x-axis to, your amplitude is going to be kind of going off plus or minus from your x-axis. So there is a shift up 2. So now the line, the horizontal line y equals 2 is your new x-axis, okay? So we do have an amplitude of 3 now on this particular graph. So we're going to be going up 3 and down 3 from the axis, which is y equals 2. This is the reflection or the shift up 2 units, okay? So we haven't had a translation left or right because we don't have a c value, but our wavelength, okay, is shorter. It's going to be pi units long, so you can just mark that. There's pi, and then here is 0, and then you can just kind of sketch out from 2, okay, that's going to go up to what? Well, if our amplitude is 3, 2 plus 3 is 5. So at 5, it's going to bounce. And then from 2, if we subtract 3, that's going to go down to -1. So you can kind of study this graph right here, and you could put in many more points. You could put in these other critical points as well, and maybe your teacher would like you to do that. So again, these problems can take a considerable amount of time. Definitely use graph paper and pencil. Okay, don't use pen, don't try to freehand this stuff, and take your time. But the main thing here is this: if you don't understand any aspect of one problem, you need to get your questions clarified. Okay, in other words, do one problem perfectly right, understand completely everything that's going on with one problem, and then you can move on to other problems, okay? And this is the graphs of sine and cosine are pretty much the exact same, approach. So you can see the equations here are basically the same. This is just cosine, this is sine. But when you get into tangent, that's a different deal. Okay, then you can get into cosecant, secant, cotangent. There is a lot to learn. Okay, so I mean, just imagine trying to take a course like this without taking any notes. I mean, it would be totally confusing. So when I stress note taking, I really do mean what I say. All right, but listen, if you're at this level of math, that already means that you are a strong math student, okay? But it gets, difficult for a lot of people. If you need help with this stuff, definitely check out my pre-calculus course. I'll leave a link in the description as well, directly to my pre-calculus course. But here's the deal, okay? good news and bad news, all right? So the good news is this: you're going to learn much more mathematics beyond this. So you're saying, oh, wow, isn't that exciting? But the bad news is that you're going to be dealing with even more challenging things, okay? So math is kind of, continues to go higher and higher and higher and higher. And yeah, it gets more complex, but it also gets more interesting and more powerful. So the more you learn, the more you can do. All right. So don't give up. And hopefully this little video helped you out. If that's the case, don't forget to like and subscribe again. And with that being said, definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.